Hello learners, welcome to the second lecture of time value of money. If you remember, in the previous lesson, we learnt about present value of money. Today we are going to learn about future value of money. Present value we have already learnt, and once we learn about future value of money, thereafter we will go for the practical application of time value of money. Now when we say we have to discuss future value of money or even for the present value of money, we need to understand different patterns of flow of money. If you see, pattern of flow of money can be of four types. Number one, lump sum amount. That means we are referring to one single amount to be paid or received at a particular point of time, either at the end of 1 year, 2 year or 3 year. So that is single amount or lump sum amount. Then we have an annuity. An annuity is a series of payments which continues for a definite time period with regular interval. Then we have uneven cash flow stream. That is, we are getting amount year on year or month on month, but every time amount might change. Amounts might not remain same year on year or month on month. So that is uneven series of cash flow streams. And we have perpetuity. But remind you, when we were discussing about present value of money, we had learnt about how to calculate present value of a perpetuity. But future value of a perpetuity can never be calculated, because perpetuity has a one condition, that flow of money continues for an indefinite period. Therefore, future value calculation for a perpetuity is not feasible. So when we discuss about future value of money, we will be discussing about future value of lump sum amount, future value of an annuity, regular annuity as well as advance annuity, and future value of uneven cash flow streams. Now, future value of money. Future value is the amount that the present value of an investment will grow to over a number of years. Let us say you have deposited X amount today for a period of 5 years, and the bank in which you have deposited the money offers you 7% interest compounded annually. So when we say future value, that means your deposited amount, that is X, plus interest earned on that money year on year, that will both put together, principal amount and the interest will become the future value. That is also known as compounded value or compound value. So future value is the amount to which a present sum of money will accumulate at a future point of time. Now, how do we calculate future value of money? So concept is simple. Future value of lump sum amount or single amount can be calculated by applying this formula. PV is the amount which we are depositing right now. R is the rate of interest which you will earn as interest on your deposited amount, and N is the time duration. So if you apply this particular simple formula to calculate present value of lump sum amount or single amount, you can calculate future value of the money. It means present value is the money we deposited and we are interested to calculate future value. R is the rate of interest and N is the time duration or tenure of deposit. Now, more importantly, future value depends on two things, or rather three things: rate of interest which you are going to earn on your deposit, tenure, that means time period for which you are depositing the money, and the compounding frequency. When we say compounding frequency, by default, compounding is done annually. But when we talk about deposit in a bank, default consideration for compounding in a fixed deposit is quarterly. So if you are attempting a theoretical question in your examination, compounding frequency is not given. Always assume compounding is done annually. It means whatever interest you earn for the first year, that will get clubbed with the principal amount, and in second year you will earn interest on that interest also. So let me explain you how compounding works. At 0 time you deposited 1000 rupees in a bank account. You are earning the interest, let us say at the rate of 10%. So first year's interest is 100. First year's interest will be 100 because annual compounding is there. It means by the end of 1 year, your money with the bank is 1100. Now in second year, that means by the end of second year, how much will be the future value? Simple concept. During the second year, you will earn interest on 1100 rupees at the rate of 10%. So second year's interest is 110. So now you can see at the end of year 1, your accumulated money was 1100. At the end of year 2, 1100 plus 110, so it becomes 1210. Come to the third year. In third year, bank will give you interest on 1210 at the rate of 10%. So the third year interest is 121. So now if you are interested to get back your money at the end of third year, so what is your money in the bank at the end of third year? 1210 was your accumulated money by the end of second year, and 121 is the interest you have earned in the third year. So your total money becomes 1331. That means to say, simple question gets framed. If you deposit 1000 rupees today in a bank account, which offers you 10% interest compounded annually, and deposit continues for 3 years. So at the end of third year, its future value or compound value will be 1331. 1000 is your principal amount and 331 is your interest earned for 3 years. So this was the mechanism to calculate manually or in a layman's language. But suppose this deposit continues for 20 years, 50 years or 30 years. Calculating like this will be a cumbersome process. So what we are going to do, we will apply this particular formula to calculate the future value of lump sum amount. So now you can see the timeline. At the 0 time you have deposited rupees 1000, and at the end of third year it becomes 1331. How do we apply the formula? You can see that future value is equal to PV multiplied with 1 plus R raised to the power of n. FV3 means future value at the end of third year. 1000 multiplied with 1 plus 0.10. Let me remind you, 10% means 0.10. 12% will means 0.12 and like that. So while plugging into the formula, take care. So it means 1.1 raised to the power of 3. So 1.1 raised to the power of 3 gets you 1.331. And 1000 multiplied with this, so 1000 was your deposited amount. So future value at the end of third year becomes 1331. So this is the way we can do it. So that is the simple approach to calculate future value of single amount by using the formula approach. Now the same thing we can do with the help of a table also. So there is a future value of money table also. So let us focus on one more example. Let us calculate how much would you have at the end of 1 year if you deposit 700 in a bank account that pays 10% interest each year. So simple concept. If you deposit for 1 year, it will become 770. And if your deposit is for 5 years, so if period of deposit is 5 years, then future value will be how much? You can see 700 you have deposited today, 1 plus 10% is the rate of interest, and duration is 5 years raised to the power of 5. You can use your calculator and then you get the answer 1127. So 700 is your principal amount and rest is the interest earned during these 5 years. So that is the way we calculate future value of lump sum amount or single amount. So this is the again timeline. This is the what question you have to solve on your own. 7,000 deposited at 0 time, rate of interest is 12%. How much will be the future value at the end of 4th year? I hope it is a simple step. You can do it very well. Let us proceed further. Alternative approach. Now, so far what I had discussed with you, while calculating future value of single amount, we can use the formula approach. Formula is simple. Let me give a recap of the formula. Formula is simple. FV is equal to PV or the amount deposited multiplied with 1 plus R raised to the power of n. R is the rate of interest and n is the time duration till which the deposit continues. By applying that simple formula, you can calculate it. or if you are handy with the table, time value table is also there, future value of rupee 1 or future value of single amount or lump sum amount. You can refer to that table. I'll show you how to refer to that table also. So let us proceed. Value is calculated like this: amount multiplied with FVIF, future value interest factor at a particular rate for nth period, and we can calculate that. Now when we refer to the table, I have the ready table for you also. You can see in this table what we have. If suppose rate of interest is 6%, and at this point of time you can see n, that is the duration. If you are depositing the money only for 1 year, you will pick up this factor. If you are depositing the money for 3 years, you will pick up this factor. Now what this table is telling us, that if rupee 1 is deposited today for 3 years, its future value at the end of third year will be 1.191 at the rate of 6%. If your rate is 10% and you are making a deposit for 12 years, then rupee 1 which you deposit today, its future value at the end of 12th year will be 3.138. 1 is your own principal amount, remaining is the interest you have earned during these 12 years. So that is the way these tables are ready reckoners, can be used anywhere by anyone. So that was future value of single amount or lump sum amount. Now let us proceed to the concept of future value of an annuity. An annuity is a series of equal amounts or payments which continues at a regular interval for a definite time period. Default consideration is at the end of every period you will pay or receive the money. However, we can also have an advance annuity also, which is called as annuity due. It means now concept is worth learning. Ordinary annuity is also called as deferred annuity, in which at the end of every period flow of money will take place. An advance annuity is the one in which money is flowing in the beginning of each period, and generally that is the feature when we open a bank account or deposit the money in the bank, that at 0 time we make the money, and then at successive year or successive month we are depositing the money. So in annuity, condition has to be satisfied: same amount every period, regular interval and definite time period. If flow of money is at the end of the period, it is ordinary annuity, regular annuity or deferred annuity. If flow of money is in the beginning of every period, it is advance annuity or annuity due. Now, what is the formula for calculating future value of an annuity? Future value of an annuity can be calculated: A, which is the amount of annuity, multiplied with FVIFA, future value interest factor for an annuity at a given rate for nth period. Now let me remind you, if your annuity is annual annuity, if your annuity is with annual interval, then R has to be yearly R. R has to be yearly R. If your annuity is monthly, then definitely R has to be monthly. So that precaution you have to take while calculation. For a monthly annuity, rate of interest has to be monthly. For quarterly annuity, rate of interest has to be quarterly. For half yearly, it has to be half yearly, and so on. So that precaution I hope you will take care. I is the rate of interest. So formula, either you can say it I or R, 1 and 2 are the same thing. It is the rate of interest. Now by applying this formula, we can calculate this factor also. So this factor can either be located in the future value annuity table, or we can apply this formula also to calculate future value interest factor for an annuity. So this is again another table, future value of an annuity. Now how to read it? On the top you can see rate of interest. Let us say your bank offers you 7% rate of interest. Every year you are depositing rupee 1, because this table is for rupee 1, and then whatever is your amount, you can multiply this table value with that amount. So you are depositing rupee 1 at the end of every year, remind you, at the end of every year in that bank account, let us say only for 5 years. So what is the value we get? Below 7%, and in the row of 5th year, we get it 5.7507. That means every year you deposited 1 rupee, so total 5 rupees were deposited, but it becomes 5.7507. So this is the future value of all those 5 rupees which you have deposited in the bank account. Now if you are say you deposit 9,000 rupees every year for 5 years and rate of interest is 7%. So multiply that 9,000 with this particular time value factor and you will get your answer. You will get the answer how much it will be. How much it will be. So that is the way we can use the table. Or if you are interested, or that no, I will not use the table, rather I am interested to calculate on my own. So you can calculate that factor like this: 1 plus I or R raised to the power of n minus 1 upon I. So let me depict it. Rate was 7%, so it becomes 1.07 raised to the power of 5 minus 1 upon 0.07. So precaution you will take, 7% means 0.07. So let us solve it out. 1.07 raised to the power of 5 gets you 1.40255 minus 1 divided by 0.07. So what answer you are going to get? 5.7507. 5.7507, and you can see table also gave you the same factor. So either you use the formula approach or you use the table, answer is going to be the same, only difference will be there, approximation. We have taken up till 4th decimal. In few tables you might find it up to 2 decimal, 3 decimal and something like that, but general standard is up till 3 decimal. Now we can take an example of the regular annuity. Suppose you will deposit rupees 100 per year in a bank account for next 5 years. If rate of interest is 9% per annum, then how much is the future value at the end of 5th year? Solution is simple. In this case, A is your annuity amount. That means every year you are depositing 100, and so future value of an annuity of rupees 100. So 100 multiplied with FVIFA at the rate of 9% for 5th year. Again, either you can calculate it on your own using the calculator, or you can refer to the time value table. So time value table tells us what is the 9% 5-year FVIFA. So let us see, is this the correct one or not? So if you go to this one, 9% comes from here, and 5 year is on this side, 5.9847. So let us go to our example where we were taking the solution. You can see 5.9847 multiplied with 100, 598.47. So this is the way we can calculate future value of a regular annuity. Let us proceed further. Future value of an advance annuity. Suppose you will deposit rupees 100 per year in a bank account for next 5 years. If rate of interest is 9% per annum, then how much this interest will grow to at the end of the 5th year? Now, since we are talking about an advance annuity, that means every year you are depositing the money in the beginning. How you are depositing the money? Let me depict it on the timeline. So this is the 0 period. You deposited 100 at this point, then 100 in 1st year, 2nd year, 3rd year, 4th year and 5th year. Now last money which you are depositing is in the beginning of 5th year. So incidence of deposits are only 5. 1st year beginning, that means 0 time, 2nd year beginning, 3rd year beginning, 4th year beginning and 5th year beginning. But maturity of the money or future value will come at the end of 5th year. It means this becomes an advance annuity. So how do we calculate future value of such advance annuity? So it is simple. Use the formula as depicted here. You can see A is the annuity amount, which is also called as PMT. FVIFA at the rate of 15% for a certain rate of interest for nth period, and 1 plus R is the extension for advance annuity. So 100 multiplied with the FVIFA at 9% for 5 years, and 1.09 because you need the extra compensation for depositing advance money. So here we get it 100. This factor you remember last time also we used for 9% 5-year annuity table, and multiply that with 1.09, so it becomes 652.3323. Now you can see when we were talking about regular annuity, amount future value was less. When it is advance annuity, future value is more. Definitely, since you are depositing money in the beginning of each year, you need compensation extra for 1 year. So you can see in advance annuity amount becomes 652, and in regular annuity amount becomes 598. So the difference is due to making advance payment. So this is the way future value of an advance annuity can be calculated. So dear learners, so far what we have understood about? We have understood about future value of lump sum amount. We have understood about future value of regular annuity. We have understood about future value of an advance annuity. Now we will learn about future value of uneven series of payments. Take care, at that point of time duration needs to be calculated. So let us take an example. Let us say 1, 2, 3, 4, 5. So these are the years. You will deposit. So amount which you are going to deposit is 1000 at the end of year 1. So right now I am taking an example that at the end of year 1 you will deposit 1000, at the end of year 2, 2000, again 1000 at the end of year 3, then 10,000 in 4th year, and 5,000 in 5th year. So these are the amounts which you intend to deposit in a bank account, which offers you 6% interest compounded annually. Now you are interested to know how much will be the accumulated money at the end of 5th year. So simply, either use the time value table and get the factor, but before that you need to find out how much will be the duration for each amount to earn the interest. How much will be the duration? Now look at the fact. You are depositing this money at the end of 1st year, and that is the end of 5th year. So practically just count on the gap 1, 2, 3 and 4. So the 1000 which you deposit at the end of 1st year will earn interest only for 4 years. Similarly, 2000 which you deposit at the end of 2nd year will earn the interest only for 3 years. Likewise, this will earn the interest for 2 years, this will earn the interest for 1 year, and this will not at all earn the interest. Why? Because you have just deposited the amount, and at that point of time you want to find out how much is your accumulated money or future value in the bank account. Therefore, what we will be doing? We will be referring to the table at 6%, because my rate of interest is 6%. We will pick up the factor for 4 year, 3 year, 2 year, 1 year and 0 year, and accordingly we will do it. So let me right now calculate it by using my calculator. So 4th year factor you can find in the table 1.262. I am using up till 3 decimal places. Then similarly 1.06 raised to the power of 3 gets you 1.919. Similarly 1.06 raised to the power of 2 gets you 1.124, and then this will be 1.06 and this will remain 1. So that is the way you have to take the precaution. You have to count on the duration, that how long this one period of money will earn interest up till the maturity. Similarly, how long this 2nd year money will be earning interest up till the 5th year. Now simple concept, multiply this 1000 with this factor, that will be the future value of that 1000 which you deposit at the end of first year. Similarly, multiply 2000 with 1.91 and likewise you can keep on multiplying, and finally you will get the future value of money. So this 1000 becomes 1262, this 2000 multiplied with 1.91 becomes 3820, then 1000 multiplied with third year's corresponding factor, so 1124, then 10,000 multiplied with 1.06, so 10,600, and lastly you have deposited 5,000 which earns no interest, and if you sum up all those amounts you will get the accumulated money in your account, that is future value of money. So take care, incidence of deposit, it is at the end. I will take another example also. So let us proceed further. So now suppose you have a situation like this. Year 1, 2 and 3. Now every time you are depositing the money in the beginning of the year. In the beginning of first year, you deposit say 3000, then 3500 in the second year beginning, and 4000 in the beginning of third year. How much is the accumulated amount at the end of third year? To remind you, you are making a deposit in the beginning of each year, but you are interested to calculate future value at the end of the last period. Now in this case, count on the duration or n which will be applicable for the formula if you are using the formula approach. So you can say this will have 3-year duration, this will have 2-year duration, and this will have 1-year duration. So let me write it again, 1, 2, 3, that is the beginning of each period, and we are interested to get the value at the end of third year. Amount is 3000, 3500 and 4000. So what will be the duration? Duration of this will be 3 years, 2 years and 1 year. So that is the amount which you have deposited. It means if you are referring to the time value table, so you will go to the table and let us say rate of interest is again 7%. So FVIF at the rate of 7%. So while locating in the table, you will go to the simple table, that is future value of rupee 1, that is future value of lump sum amount. Find out the factor corresponding to third year, corresponding to second year, corresponding to first year. Because now last year money which you are depositing in the beginning of third year will also earn the interest. Therefore, last year money will earn interest for 1 year. So its factor will be 1.07. Then second year factor 1.07 raised to the power of 2. So 1.1449 and then 1.07 raised to the power of 3. So 1.2250. So these are the corresponding time value factors. Now we can get the future value. Simply 3000 multiplied with 1.225. So 3000 multiplied with 1.225. So we get it 3675. Then 3500 multiplied with 1.1449. So 4007. So let me verify it again. Perfect. And then 4000 multiplied with 1.07, 4280. And when we sum up all these, 3678 plus 4007 plus 4280, So that makes it 11,965. 11,965, whereas how much we deposited? We deposited 10,500. So the difference is the interest which we have earned during these 3 years. So we have taken uneven series deposit at the end of respective period as well as in the beginning of each period. So take care whether it is beginning or end, but remind you, in an examination, by default, if nothing is given in the question, we consider amount is flowing at the end of respective period. So dear learners, that was the concept of future value of money taking annual compounding. Now sometimes you might be surprised if compounding is monthly, quarterly or half yearly, then how to calculate the future value. So let me discuss that also, and let us proceed. So let us say you deposit 5,000 rupees in a bank account at time 0. So if I put it on the timeline, so this is your 0 timeline, and you are making a deposit for 5 years. You are depositing 5,000 today, and bank offers you 6% interest compounded quarterly. That means 4 times in a year, because there are 4 quarters in a year. Now how to apply the future value concept in quarterly compounding? So quarterly compounding, we can have the same formula, FV is equal to amount multiplied with 1 plus R raised to the power of n. But take care, since your compounding is being done quarterly, so this R, you can use it I also, because formula is interchangeable, 1 plus I also, so both the formula are available. So I or R, which is the rate, it must corresponding to the compounding frequency. So since your yearly rate is 6%, so quarterly rate will be 1.5%. So you are depositing 5,000 today. Quarterly rate is 1.0 plus 0.015, because 1.5% will be written as 0.015 raised to the power of n. So first thing, divide the yearly rate by 4, and n, since you are continuing the deposit for 5 years, but in the formula n will be 5 multiplied by 4, that is 20. Now why 20? Because you might be surprised that I am depositing money for 5 years and why n is 20 in this case. But dear learners, there are 20 quarters in a total period of 5 years, because every year 4 quarters, and in 5 years we have 20 quarters. So it will be raised to the power of 20. So now we have 5,000 multiplied with 1.015 raised to the power of 20. If we use our calculator, so we will get it 1.015 raised to the power of 20. So we get it 1.3469. That means 5,000 multiplied by 1.3469. So 1.3469 multiplied by 5,000, you get it 6734.50. So that is the way. If it is quarterly compounding, then definitely number of quarters will be your n, and rate will correspond to the quarterly rate. If it is monthly compounding, then in the total duration number of months will be your n, and rate will be monthly. So that precaution you have to take. So if you are handy in using the calculator, you can straightway use your calculator and work it out. Now you can see the difference. When rate is quarterly compounding, future value is 6734.50. Just note down that value, because I am going to depict with you. If it is yearly compounding, then how much will be the future value? So we can work it out. So let us say same example, 5,000 deposited at 0 period, duration is 5 years, rate is 6%, but now this time compounding is yearly. It means your formula will work like this, 5,000 multiplied by 1.06 raised to the power of 5. So we get it 1.06 raised to the power of 5. So you get 5,000 multiplied by 1.3382. So 1.3382 multiplied by 5,000. So you get 6691. Whereas in our earlier case, how much was the amount? It was 6734 somewhere. So you can see the difference. More the compounding frequency, more will be the future value. Less the compounding frequency, less will be the future value. It means ultimately future value is also dependent upon compounding frequency. Future value is also dependent upon compounding frequency. So dear learners, that's what we have learnt about future value of lump sum amount, future value of uneven series of payment, future value of an advance annuity, future value of a regular annuity. So that's all in the future value. In the subsequent lesson, we learn about the practical application of future value of money and present value of money. That practical implication will be much more interesting, much more useful in the day-to-day life, even for the, no doubt, for finance people, but for non-finance people also. Till then, keep on learning, keep on watching the video. Thank you.